Well, hello everyone. This is KP the Math G. Uh, I better get on this. My camera runs out in about a little over 30 minutes, maybe 31 minutes, and so I better get with it on this one. This one's going to be a lengthy discussion, so sit back, and if you have popcorn, just rear back and eat your popcorn. That's good. All right, well, let's get started. All right, area between two functions is what we're dealing with. One of these, obviously these two are lines. One of them is G and one of them is F. And I wonder if I'd labeled these, if you could figure out which one G or F is. And looking at that, I bet you would know that since this goes through 0, 0, since G goes through 0, 0, there's G. And of course it says G anyway, right? But okay, your y-intercept's at the end, and you don't have you do have y-intercept. It's at 0. But anyway, all right. F of x is the pink. F is the pink line, and we want to find the area of underneath all of this. Okay, kind of a triangular. It is a triangular section here. Well, how to do that? Well, there are two ways to do this, and one way is easier than the other, okay? But we're going to do the harder one first, okay? So let's go ahead. I can't, I need a place to draw my partition, and actually, if I draw it on this one, I just touch this line. I touch G. If I draw a partition here, like this, kind of draw a partition like this. Oh, well, anyway. Alright, like that. I come down. But that only gives me, if you look at that, this is only giving me the area underneath G right here and straight down. It does not cover this section from 3 to 4. So I need to draw another partition that touches F as well. Do you see that this only goes, if I go from 0 to 3, I'll get to where they intersect. So what you want to do is you need to find where they intersect. Well, I found that for you. It's 3, 4. But remember from the last video, you can find it when you set these two equal to each other. Okay, and solve for x. And you'll get two answers, of course, actually one, and you'll find out where they intersect. That's the one place that they intersect right here. I said two answers. I was thinking, never mind. This up here, you'll get x equals 3 if you solve, and then you'd find the y value by plugging it into either one of these two. You could get 4 very easily. Okay. So I want to find this from 0 to 3. I've got this area right here. I need that other area from 3 to 4, so I need a partition right here. Alright, and alright, like that. That's gonna, oh boy, okay. This line is so steep, it's hard to make a partition. I make it wide enough where you can see it. That's the reason I make it so wide. Alright, now I've got it. So I want this from 0 to 3, but now that's only G. See, I don't have to worry about F until I get from 3 to 4. Alright, so just G. So I'm going to make my integral from 0 to 3, and I'm only touching, this is only touching, if I put this I subinterval anywhere, it would only go from 0 to 3. Slide all the way from 0 to 3. Where the x, where they intersect, right there. Alright, so this is G, so that is 4/3 x. 4/3 x. Okay, now I want to get that, and then I want to add to that. The rest of it is from 3 to 4, isn't it? Alright, so from 3 to 4, I'm graphing, finding the integral, definite integral, from negative 4, or negative 4x plus 16 dx. Now you realize that 4/3 x is how high this is. This is 4/3 x. Alright, delta x is here, but we call that dx here. Negative 4x plus 16 is how high this is. How's that? I'm touching that y value, right? Alright. And this is the thickness of it, delta x. Now I have it. And this is part of the way of learning here. You got to learn that if you see an intersection, then this may be the easiest way to do it. Okay, and that's the reason why I have to show both ways. There's another way to do it. I may have to show it in another video, but anyway, let's see what we can do now. Okay, we know how to integrate this. Okay, so remember, this is to the 1 power. Another marker. Alright, so let's see, this is equal to, alright, so 4/3 x, leave a little space here because x, alright, remember I'm squaring that, add 1 to 1, I get 2, and I'm dividing by 2 here, alright, and then I've got that part right there from 0 to 3 here. Alright, I'm going to go ahead and look that and see what that is. Okay, let's see. I think 4 can go into 2. 2 goes into 4 2 times, rather. Alright, so now I'm left with 2/3 x squared. Okay, and from 0 to 3. Okay. Alright, just making sure I got all of that. Yes, I do. Alright, so now I'm going to plug the 3 in. Alright, so that's equal to 2/3. I'm going to leave that separate. I can do that. So 3 squared minus 0 squared. Alright, that's 9. So 9 times 2 is 18. Alright, so 2/3 times 9. And we see that 3 goes into 9 3 times, and 2 times 3 is equal to 6. Alright, equal to 6. Alright, so this region here is just 6. Alright, I need to figure out the other region. Okay, so if you will, I want to erase this so I can do this other one. And I don't like flipping this board over because I'm just going to lose you, I think, and I'll lose where I'm at. Alright, so this one here is equal to 6. So I have this one. Alright, equal to 6. Alright. Alright, so let's find out what this one is now. Let's see. I can go ahead and do it from here. This is equal to negative 4x squared over 2. Alright, plus 16x. And I'm going from 3 to 4 on this one. So from 3 to 4 on this one. Alright, like that. Okay. Alright, let's go ahead and plug those in there. Alright, so let's see. This is going to be negative 2x squared plus 16x. Alright, from 3 to 4. Alright, here we go. This is negative 2 times 4 squared plus 16 times 4. Remember, I got a minus sign on this, so minus negative 2 times 3 squared plus 16 times 3. You got to remember, you do have a minus sign here. Keep in mind, this is F at B minus F at A, like that. Always remember that an integration is that, okay? Alright, let's go ahead and finish this. 4 squared is 16. 16 times negative 2. 16 times negative 2 is negative 32. Oh, let's see, negative 32 right here. Alright, 16 times 4 is 64, plus 64. Alright, minus sign. Let's see, minus here. Alright, so 3 squared is 9. 9 times negative 2 is, so 9 times negative 2 is negative 18. Negative 18. And then 16 times 3 is 48. I taught math so many years, I can just look at 16 times 3 and say 48. Okay, now let's see. We know that in here, well, let's see, this is negative 32 plus 64. 32 is half of that, so the top portion is, let's put it up here. Let's put the answer right in here. So the top portion is 32 minus, alright, let's see, this is negative, this is positive, I need to subtract. Negative 18 plus 48 is 30. And this answer is 2. Now, remember the other one was 6. Alright, so all of this is equal to 2. This part right here is equal to 2. Alright, this part is equal to 6. 6 plus 2 is 8. So the whole area, the entire area now, from here to here, first is 6. Then the rest of this is 2, which I thought it would be because I already knew the answer to this. So the whole thing is 8. All of it together. That's one way to do it. And sometimes, based on the problems, as we get into Ln and E and sine and cosine and tangent and all the secants and all that, and you know, this may be better. Now, sometimes it's so you can't integrate from what we have learned, and sometimes you have to allow your calculator to integrate for you. My calculator can do that, but mine doesn't have all the newer features that perhaps yours does. I'm going to have to just break down and get me a better calculator that can integrate. Okay. Alright, so I'm going to leave this part up here. I'm going to leave my figure up here, and I want to do it another way, by the way. Alright, so let's do a lot of erasing. Okay. And bear with me. I appreciate everyone who's tuning in and watching this. I appreciate everybody. I know that many of you are going in a route where you need calculus, and hey, I applaud you for that. Calculus is, you know, I mean, you think, well, how will you use it? Maybe you just don't realize what you're doing when you're studying calculus. You're picking up tools so that you can learn other things, like how to be a physicist, or how to be an electric engineer, or maybe a mechanic, some kind of engineer. Everyone who goes through engineering does go through calculus, and other areas as well that calculus is required. There are business applications. Calculus deals with business applications as well. So there's so many areas that calculus can be used. Well, let's not tarry any longer, because I know my my recorder there is old, and it cuts out with me not even knowing it sometimes. But I do have a light that blinks, and when it stops blinking, I know that it's time to stop, or it stopped for me. Alright, I'm still going to find this area, but look, I'm not going to draw the partition perpendicular to the x-axis. Remember, if you draw a partition perpendicular to the x-axis, you're going to leave everything in terms of x. Alright, now, I'm going to do this now. Maybe I can ignore this somehow, ignore that these are intersected here, and perhaps maybe I can go this way and work with that. Let me show you what I'm talking about. Maybe I can find the area going this way. Alright. I'm really looking for this area in here, but I want to subtract off this. Alright, so remember there was a problem that we had where I had F over G, you know, that was about 2 or 3 videos ago, and I said that you subtract off the top minus the bottom. Well, the same thing is true here now, except you subtract F, the furthest one to the right. So when you integrate from A to B, in this case, you're going to integrate F. Alright, actually it's going to be, instead of X, it's going to be Y instead. Okay, well, F at X minus, actually it's well, okay, F at Y, and I'll show you why it's that in just a moment, minus G. It is actually, let me just do it this way so you won't, okay, it is the right function minus the left function. Okay, alright, and I will show you in just a moment that that is dy. Okay, alright, so I'm just going to let you see this. Alright, so that's what I'm talking about. It's the right, the minus this left part right here. I'm just wanting this right here. Alright, and I'm going to show you this kind of in just a moment. Alright, the right minus the left. And that's always the case no matter where it is on the graph. Right minus left. Okay, now, if we're going to do something that's perpendicular to the y-axis, we need to solve for x. If I'm doing something perpendicular rather to the x-axis, I want to leave it in terms of x. Make sense? Okay? Alright, now, this distance from here to here, and I know, it's going to F, isn't it? We're going to call this x2. That is x, isn't it? I mean, ever how far that is from here to here, it's almost 4, 3 point something, you know. But we don't care about that. This is x2. This distance here is x2. And I want to subtract off this hollow part right here. I want to subtract that part off because I just want this inside here. This is x1. And what I want is this part right here, which is really x2. We'll call it x3, which is really x2 minus x1. So this region here, we're going to name it x3. But it's this entire length minus this x length here. But to get x, I must solve for y. So let's make this equal to y instead of g at x. So g at x is equal to y. But y is equal to 4/3 x. Alright, I want to solve this for y. Let's just leave that g at x off of there. Alright, now I want to solve this for x. Alright, because this is x here. Alright, this part right here, this is g. Alright, this is g. This is x right here. This is actually x1. Alright, x1. My markers are starting to fade. I have to buy some new markers. Alright, let's get some more right here. Okay. This is x1 right here. I'm just going to put a colon here. x1 is this. Okay, x1. That's this distance from here because I know that because I'm touching this line of g right here. Alright, now I'm going to solve this. Alright, let's see. I'm going to multiply this side by 3/4 and this side by 3/4. So what I have here is x1 is 3/4 y, and then of course all this divides out and that equals x. So x, this is actually x1 right here. Alright, x1, got it. 3/4 y, huh? Okay, there it is. Alright, I want this one here solved for. We'll call this one, this length here is going to f. That entire length is going to f. Alright, so this is x2. Alright, so let's see. Y is equal to negative 4x plus 16. Okay. So if I solve this, if I subtract 16 on both sides, I'm going to have y minus 16 is equal to negative 4x. Alright, if I divide both sides or multiply both sides by negative 1/4, I'm going to get, alright, so times negative 1/4. Alright, so this is negative 1/4 y minus 16. Alright, so this is x of 2. Alright, that's equal to x. These are gone. Alright, and so x, we're going to call that x2. Alright, so x2, alright, x2 is negative 1/4 y minus 16. Alright, I hope I don't run out of time. Alright, now I'm going to subtract, remember, x of 2 minus x of 1 so I can get this x of 3 right here. Alright, so x of 2, that length minus, take away this part right here, I'll have this right here. Alright, so let's do that. Alright. These kind of things take a little while, but luckily for us, they're just straight lines, so linear equations are just so much easier to solve. Alright, that's probably why I chose them, huh? Alright, so I gotta remember x2. So I'm actually going, no, wait a minute, let's see. This interval is, if I keep going this way and this way, alright, I'm going from 0 to 4. Now we don't use the x values now, we use the y values. Okay, when everything's in terms of x and well, we got everything's in terms of y now, well, we got to use the y values. Makes sense? Alright, so here's what we got. We got from 0 to 4. From 0 to 4, we've got a negative 1/4. Alright, y minus 16. Okay, that part minus 3/4 y. Alright, all that. Now not delta x, but delta y. This right here is delta y here. Okay? Alright, that's part of it right there. Just to realize that it's the right, if you don't remember, the idea behind what you're doing here, just remember it's the right minus the left. Always remember that. The right minus the left. No matter where they are on the graph, the right minus the left. Okay? Alright, so that's it. Alright, so let's go ahead and figure this out. Alright, one thing about it is we can kind of, let's multiply this and see what we get. Let's kind of fix it up. Alright, so negative 1/4 y, 1/4 y, minus a negative is positive. Alright, 1/4 times 16, 1/4 negative, well, times negative 16. Alright, 4 goes into 16 4 times, 4 goes into itself 1 time, so plus 4 here. Alright, so minus 3/4 y dy. I can still group these two together. Alright, that's looking real good. Ooh. Let's see, where can I put it? Let's put it up here. Alright. Ooh. Tell you what, let's do, now let's look at it over here. I may flip the board over. Alright, let's bring it up here. Alright, from 0 to 4. Alright, negative 1/4 and minus 3/4 is negative 4/4. Alright, y plus 4 dy. Man, if I can shrink something up, I will do it. So this is just negative 1y right here. So negative 1y. Wow. Right there. And now I'm going to erase all of this, trusting that I got everything correct, or done everything correct. I think I did. Alright, let's see. Alright, I'm going to erase this. Alright, so let's see. Now I can integrate this. Easy to do, isn't it? It's just setting it up. It takes a little time to do, right? Alright, so let's see. Negative 1y squared over 2 plus 4y. And we're going from what? 0 to 4. Yeah, 0 to 4. There it is, right there. Alright, so I'm going to plug in 4. Alright, so negative 1 times 4 squared over 2 plus 4 times 4 minus, alright, negative 1 over times 0 squared over 2 plus 4 times 0. Well, all of this, you know what this answer is, right? This is 0, isn't it? Alright, so let's see. 4 squared is 16. 16 over 2 is 8, so negative 8. 4 times 4 is 16. And then negative 8 plus 16 is positive 8. Now, if you remember from our last, when we did our last problem the other way, we got this to be 6, and we got this to be 2, and together it is 8. And when we went this way, we got 8. So in summary, what you got to remember to do, guys and girls, is remember that if you're going this way, which is in this case easier, not always is that true. You can do this one time if you solve both of these. Since this is x, you want to solve, you want to get it x equals. Okay? X equals. And it happens to be in terms of y, but that's alright. Alright? And so the right one, this one, minus this one. Okay? And that's what we did. Okay. So that's pretty much what I have here. Let's do, if my camera goes off, I've done everything I need to do, but I do want to show it one more time from 0 to 4. Why is that? Because we're going from 0 to 4 here. I'm not going to do the whole problem. but I'm just going to set it up one more time. Alright, remember we solved this. This is y. 4x plus 16. Very quickly, I'm just going to undo this. So y minus 16, and we have 1/4 here, didn't we? And that is F. So I'm going to put F first. F first. Okay. And then I want to do G second. So this is y. Just put y there in place of G at x. Is equal to 4/3 x. And then this is now 3/4 y is equal to x. So 3/4 y. So minus 3/4 y. And remember dy like that. Okay. And of course, as we did, you can